Hello, everyone. Mr. Sutherland here, continuing our chapter on probability and statistics. So we just finished 11.6, which is on different ways that you can count things, arrangements of things, and now we're going to move into probability. So we have a couple of just key ideas. This is just basic probability. We'll get into more advanced stuff next week. But we'll start with just basically what is probability, finding the probability of events, finding the odds that an event will occur, the difference between the two, theoretical versus experimental probability, and also looking a little bit at geometric probability. And then next time we'll go a little more in depth. But I just thought I'd lay out some definitions for you first. So when we talk about probability, here's the definition of probability. When all outcomes are equally likely, the theoretical probability, so what theory says should happen, that an event A occurs is, so how we figure out the probability of something is we figure out the number of outcomes in event A which A can be like, A is an event like I want to roll a 6 when I roll 2 dice. I want to turn up a heart when I draw a card from a deck of cards. That's my success is getting that happen. That's my number of outcome. And that's divided by the total number of outcomes in the set. This is most commonly referred to as the sample space. So a very simple example here is, what's the probability that I draw a jack from a deck of cards? Well, we have that there are, my event A is drawing a jack. There are 4 jacks. And then how many total outcomes are there? There were 52 cards. So my probability is 4 over 52, which is 1/13th. Sometimes those are expressed as decimals. Sometimes they're expressed as percentages or fractions. Unless otherwise state, I prefer you answer with a reduced fraction. And one of the big things here with probability is that probability has to be between 0 and 1. That old saying of give 100 to 10% is inaccurate, right? You can only have a probability as low as 0 and as high as 1. And the sum of all probabilities of all outcomes is equal to 1. And what that means, if I have a probability that it's going to rain today is 60%, that means the probability it's not going to rain is 40%, right? Those probabilities have to add up to 1. Now, sometimes probability gets confused with odds. Odds are what you see a lot in sports. And odds is a variation of probability, except so if I have the odds of something occurring, what you're going to do is it is the total successes. So very similar to how probability starts, to, and you can do colon or you could do a fraction, to, now you're going to compare it to total failures. So if the odds are 7-3, that means really there's 10 trials. They expect 7 successes and 3 failures. Now, odds against something happening, we just reverse those. We do total failures over total success. So a failure in this case means what you want to happen does not happen. That's a failure. All right, so those are the mathematical foundations that you're going to use for the rest of these problems. So what I would like you to do now is there are 9 problems. I think it would be good to try them on your own. Pause the video if you want to do the problem at a time. If you want to try all 9 at once and then come back and go through the video, that would work. But I would definitely not just sit and just have me go through the problems right now, because this is really something where your mind needs to wrestle with it a little bit. You need to kind of struggle with it. If you get it wrong, figure out what you did wrong based on my explanation. So pause the video, decide what method you are going to take to do these problems, and then go ahead and resume. All right, I'm going to just start my way through these problems. So problem 1. Imagine only 2 dice, one red and one blue, and taking the sum of the two dice. How many possible outcomes are there? So we have two dice, we have a red die, and we have a blue one. Each of those have 6 numbers on it. So if I were to write out my possibilities, this goes back to what we did last section. If I have 6 choices for the red, 6 choices for the blue, then altogether there are 36 possible outcomes that I could have. Now, we're going to build to how would I do the probability of rolling a 9 versus an 11. So we're going to build this out. Normally this is just work you would think of on your own, but I'm kind of having you step through the process here. So different ways I could roll a 9. Well, I could have a blue 3 and a red 6. I could have those switched where I have the red 3 and the blue 6. I could have the blue 4 and the red 5. Or I could have the red 4 and the blue 5. I believe that's it. So there are 4 different ways that I could roll a 9. So my probability of rolling a 9 is 4 out of 36. And make sure you use your calculators or whatever you want to reduce that. And the probability of that is 1/9. Now, what are the ways we can roll an 11? There's just 2. We could do a 5, then a 6. The red and blue, or blue and red, and then we could also do 5, 6, like that. So there are 2 ways that we could do it, and so that probability is 2 out of 36, so we get 1/18. All right, next problem. What's the probability that 5 books randomly placed on a shelf will be in alphabetical order? So let's think of first, I'm going to do it kind of out of order here. Let's think of our sample space. And the sample space is how many arrangements are there? Well, how many ways are there to arrange 5 books? And that's what we did last section. So that's 5 factorial. So there are 120 ways that we could arrange the books. How many successes are there? Well, how many ways are there to arrange 5 books alphabetically? There is only 1. So the probability that they are arranged alphabetically is 1 over 120. Number 3, a club has 9 boys and 11 girls. What's the probability that a committee of 4 people chosen will have 2 women, 2 men, and 2 women? Okay, so just like we talked about last time, the first thing I'm going to find is my sample space. In this case, it is, well, how many total committees are there? Well, I'm out of 20 people, I'm choosing 4. Order doesn't matter, so this is a combination. If I do 20 choose 4, that's 4,845. Now, in this problem, what is deemed a success? Deemed a success if the committee has 2 boys and 2 girls, or 2 men or 2 women. So that means out of the 9 boys, we choose 2. Out of the 11 girls, we choose 2. And that comes out to be 1,980. So my probability that that happens, success over my sample space. Put that in the calculator. I don't expect you to reduce that by hand, but I do want your fractions to be reduced. So that's 132 over 323. Number 4, you are randomly given 5 cards from a shuffled deck of playing cards. What's the probability that your 5-card hand contains 3 hearts? So let's start with our sample space. We are given 5 cards from a group of 52. We've done this calculation quite a bit of times. So that's 52 choose 5, which is 2,598,960 possibilities. Now our success is that our hand contains 3 hearts. Now this is where if you need that diagram again, this playing cards diagram, make sure you have that ready. You can always look at it. This got you on the last quiz because some of you, when I said number of jacks, you wrote 13, but you can clearly see there are 4 here. So just as we look at this, how many hearts are there? There are 13 hearts. And out of those 13 hearts, we want 3, but we're taking 5 cards. That means out of the other 39, we need 2. So there are 211,926 successes. So if we write our fraction, and again, please put that in the calculator to reduce, and let's keep the answers for, especially as we're entering homework into Google Classroom, it helps if we just all do the same thing. Let's keep it as a reduced fraction, but you could type that in and see what that is, a decimal or percentage, to kind of see what the rate, what it is. Number 5, consider the letters in the word table. If you randomly scramble these letters, what is the probability that the new arrangement begins with the letter B? Well, it kind of makes sense if there are no repetitions here, that the answer, if there are 5 letters, how many arrangements start with the letter B? It's got to be a fifth of them, right? But let's show mathematically how that comes out to be. So the sample space, similar to a previous problem we had with arrangements, we have the letters. We're going to arrange those. There's 5 letters, so there's 120 different arrangements. Now the success, I don't know where that came from. The success would happen when the first letter is a B, so we have one choice for that, and then we have 4 choices for the next 3, 2, 1, and that comes out to be 4 factorial, which is 24, and if I do 24 over 120, that does come out to be 1/5. So sometimes probability you can think your way through and get to a correct answer. Number 6. 6 boys and 6 girls belong to a club, 4 officers being selected at random. What's the probability they will be all girls? So similar to a problem we've done earlier. So I set up my sample space, and what I'm going to start doing for this one is let's just do it all in one line of work here instead of writing out the separate things that I've been doing. So my sample space is I have 12 and I want to pick 4. So that's a 12, choose 4. What's the probability that they're all girls? So my success is, out of the 6 girls, I choose 4. Out of the 6 boys, I choose 0. And what we end up with is 15 over 495. And actually, if you type this into your calculator as you see it, it will take care of everything, reduce it to 1/33, like that. All right. Number 7, a card is drawn from a 52 card deck. Find the odds in favor of drawing a 10. Okay, so odds. Odds are, remember, we have in favor, so we do success to failure. So, how many successes? If I draw from a 52 card deck, there are only 4 successes, right? There's only 4 10s, which means there are 48 failures. So, with this, we can reduce that. That is 1 to 12, or we can write it as 1/12. So those would be the odds. 1 success per 12 failures if you were to do this. Find the odds against drawing a club. So it's against. That means we're going to do failure to success. So I would fail to draw a club 39 times because there's 39 non-clubs. I would be successful 13 times. So here we get 3 to 1. Or we could write that as 3 over 1 or 3. Now notice, odds, you can have numbers not between 0 and 1. It's not the same as probability. Number 8. Using a standard deck of 52 cards, we're going to be selected a card of a random, recorded the results below. So we drew cards, and this is what happened. Based on the results, what is the experimental probability of drawing a diamond or a spade? Now, experimental probability means ignore what it should be, look at what your results tell you for the experiment that you did. The experiment that we did, we had 52 cards, but we drew these. We had 9 diamonds, we had 15 hearts, 5 spades, and 3 clubs. So we drew all together, it looks like our sample space was 32 cards. So the probability it was a diamond, well, that was 9 out of 32, plus the probability, because remember, or, and probability means we're going to add the probability that it was a spade, was 5 out of 32. So that comes to 14 out of 32, which is 7/16. So it looks like in our experiment, we got a heart or a diamond or a spade slightly less than half the time. Now, what's the theoretical probability? Well, the theoretical probability of getting a diamond, well, there are 13 out of 52 diamonds, or a spade, 13 out of 52 spades, is 26 out of 52, which is 1/2. So what it tells us is our experiment was, we did 32 trials, we got close to 1/2. The idea of theoretical probability is if I were to do enough trials, if I were to do thousands and thousands of trials, we would be very, very close to 1/2. That's what's going to happen. Whereas if you do a few trials, you could get results that are skewed using experimental probability. Like here, I look like I only got 3 out of 32 clubs. That's less than 10% of the time. Whereas normally if I do enough trials, I should get 25% of the time I should draw a club. But when they say experimental probability, you look at the data that you have. All right, last one. All right, some geometry here. A circle with a radius of 12 inches. So we have a circle that has a radius of 12 inches is inscribed in the square shown below. If a point is chosen at random inside the square, what's the probability that it's inside the circle? Okay, so my sample space would be everything here. And I have a square. If this is 12, that means this is 24. This is 24. So my probability of my sample space is just the area of that square. We'll just do 24 squared, which is 576. Now, my chance of success, I want it inside the circle to be a success. And inside the circle, that area is 144 pi. Now, you'll notice when you put that in the calculator that because of the pi that's there, that does not reduce any. I don't think. Let me put it in. It does if we keep it exact. This is pi over 4. And then if I do that as a decimal to 3 decimal places, I got 0.785. So what that means is there is a almost 79% chance that if you were to pick a point, it would be in that circle, which makes sense. That's where most of the space is. So when you're doing geometric probability, a lot of that's going to deal with area formulas and mixing those. So this has been just a quick intro to probability. I hope it's been helpful. Try the homework, which is a worksheet over this. You'll put the answers into Google Classroom again to see how you do. And I will talk to you again soon. Take care. Bye.